10 o'clock and it's time for us to get started. I'm happy to see we actually have quite a nice audience, even though it's a Monday morning. I will start by us introducing the format we're going to use during this PhD defense, and after that we will get started. So I'll start by introducing our opponent in grading committee. So we have Associate Professor Tanja Foss, and then we have Professor Per Unisson from Lund, we have Kai Petsen from Blekinge, and we have Magnus Viktorsson, Professor also, but here from MDH in Eskilstuna. I have two more brilliant advisors that have done lots of work together with Kristian. And first of all, we have Sigrid Dell here from Ericsson, but also full-time Ericsson, right? Yeah. And we have Associate Professor Daniel Sundmark sitting next to us. So thank you all of you. We will start this event by having Kristian to introduce and present his own work for maybe 20, 25, 30 minutes, something like that. And he's promised to do it at 11, so we will be able to follow and see the highlights of his work. The first segment will be filmed by our nice cameraman at the end, but it will only be Kristian's presentation that we film. So after Kristian is done, we'll have a short, maybe 2-minute break, just to be able to remove the camera and the extra, whatever it's called, little thing on his chest there. So we'll have a short break after Kristian is done. After that, it's time for Tanja to get started as the opponent. And the floor is open for her, and she will ask just as many questions as she needs to ask to be confident in the work that Kristian has done. And when Tanja is done, we're going to let the grading committee jump in and ask a few questions each. And when that segment is done, it's time for the audience to be allowed to ask questions on Kristian's work. And after that is done, I'm sure we're all going to be really hungry. Then it's time for Kristian and you guys probably to walk over to Java. I'm sure Kristian will show you the way. And the grading committee opponent and advisors will go and have a meeting that usually takes, 20 minutes or so, where we're going to discuss how the defense went and we come up with a grade, if it's a pass or fail. And after that, we will come and join you in the coffee room Java. And after that, anything. Okay? So once again, very welcome to Kristian Wiklund's PhD defense, where he has written a nice thesis with the title of Impediments for Automated Software Test Execution. The floor is all yours, Kristian.
Thank you, Justina. Good morning, ladies and gentlemen, viewers of the video. I'm Kristian Wiklund, and I'm an industrial PhD student from Ericsson, who together with the KKS Foundation has funded this work. I would like to point out that the conclusions and the proposals in this presentation and thesis are my own. They do not necessarily reflect the position of Ericsson. The presentation will be organized in 2 parts. One is the introduction of the work, where we'll talk a little about my background, because that's important when you do qualitative research. We look at the problem statement, a bit about the value for the industry, the objectives of the research, very short part about the methodology, and then a brief look at some the most important related work. Then we continue with the results, the contributions of the work, the research, answers to research questions, and a small, short discussion on future work. In qualitative research, many people believe that the researcher is the instrument, and then this makes it important for you to understand who I am, to understand why I have interpreted things as I have done, and why I've chosen the research that I've done. I think that it's fair to say that my experience has influenced the selection of the research objectives, the research questions, and probably also the interpretation of the work. I worked 15 years at Ericsson, almost, this December. I've done most things you can do in software development, from programming, project management, testing, test tool development, operational development, that's a discipline of improving processes, methods, and tools. And currently I work as we call it operative product owner. You're a product owner and project manager for a quite large test tool. I also have lots of friends in the software development business. Most of them work with testing, some do programming. My wife, up in the corner here, is test manager. She's worked with testing for 15 years, so it's kind of the family business. So we have a few discussions about testing, and this has of course been a great help in understanding this research for myself. The overall discipline is software engineering, and that is, according to Barry Böhm, the practical application of scientific knowledge in the design and construction of computer programs. And he's written a nice treatise on why this is important. And basically, he promotes the connection between practice and research, and that we do through the empirical software engineering research discipline, to be able to understand if what we do as scientists is important for the real world and the practitioners. Then we have to go out and study them, basically, or study ourselves in my case then. If we narrow it down, I work with software testing, and that is the most commonly used method for quality assurance and quality control in software development. And testing is basically, and I'm not going into the exact details here, but basically we execute the software with a predetermined input, and we look at what happens when it's executing. If it behaves as expected, then it works. If it didn't behave as expected, then we have found a bug. And this is not perfect by any means. We have to understand a lot of things to be able to do this. It sounds really trivial, but it actually isn't. Because software testing consists of a very large number of engineering activities. And I know that you cannot read it, and it's if you look it up, it's the ISTQB test process. And we start, it's like any other development. We start with planning, we do analysis, we do the implementation of the automated test cases or the manual test cases. Then we execute it. That's the little red box here. And execution is where we run the tests, we execute the software, and we create results that are compared to the expected results, and we get the verdict. Then there's evaluation and test closure, basically lessons learned and things like that. So test execution is a small part of the test process. One thing to be aware of here is that when people say automated testing normally, that is what they mean. But to clarify that it is in this thesis what we mean, that's why it says software test execution and not just automated software testing. So it's an important distinction, but it's usually not done. Testing is super expensive, and depending on who you ask, some 30 to 80, around 50% of the costs in a project is testing. I think it can be significantly more. And many test activities are quite boring, repetitive. We change something in the software, and then we do something called regression testing to make sure that we haven't broken something that worked before. So we do the same tests over and over and over and over again, and sometimes it's just sitting and following actions on a sheet or pulling a cable out, up, back and forth. So it could be boring, it is repetitive, etc. So it's very well suited for automation, or we want to do automation to be able to stop doing trivial things and start doing things that actually add engineering value to our product. And automation done right will save lots of time and money, as is seen in this chart, if you look at it later. Test execution automation is also proposed to be the key to agile development. And I think that everyone that's worked with software development for the last 10 years has encountered agile development. And the point, in short, is to deliver software rapidly in small testable increments. We focus on features. We don't have long development cycles. We get the product quickly to the customer. And this, since agile is the new thing in most software development organizations, it also makes test execution automation very important for these organizations. And what we want to have is quick feedback with low overhead to developers. They write code, they check it in, they submit it, it's tested, and then it's released to the customer to the next test level. And we also want to have the shortening of the release time. And there is a study from ESEM last year that showed that the majority of the time spent in the release cycle is actually spent on testing. So we can improve the test time here, shorten it. Then we can get to the customer much faster, we get the feedback on how it works much faster, and we basically get happier as developers. So, why do we do automation? And just a few points that I think is important here. We want to minimize lead time by testing during nights and breaks, because if we automate it, we can start the testing and we can go do something else. We can either drink coffee if it's a short test, or we can code the code if it's a long test, or a vacation. We want to make the testing available to anyone. That's the point in Agile, I think, that we have the code, we press a button, we get the results. We don't have to have a specialist that sit and do the cable pulling. We want to avoid error-prone repetitive work, because at least when I do the same thing over and over and over again, I get bored. And this is why pilots have checklists, for example, to prevent making mistakes. And by automation, we can remove the repetition and we can remove the mistakes caused by boredom. And then we have the rapid feedback to the programmers that we mentioned. So we want the test to make it possible to race ahead, like in this picture, full speed ahead, nice clean road. But, I love this picture because it depicts very clearly what happens when many people automate their testing. I don't know what's happened here, but the road is obviously too narrow for all the traffic. So we're trying to do too many things at the same time. There's a bend up here. Something's happening, cars are queuing up, and it doesn't really go that fast as we wanted. And the person down here is leaving the car. They don't want to be there anymore. And that actually happens to many people that try automation. They get disappointed, they don't get what they expect, so they just stop doing it. And this is the reason for my research. My goal is to further the scientific knowledge about common problems encountered by software developers using test execution automation, to be able to improve the test execution automation in industrial software development. One thing that you need to understand to appreciate the rest of the presentation is what an impediment is. And an impediment is, according to Scrum Alliance, anything that prevents a team member from performing their work as efficiently as possible. And I believe that even the most predictable things are ignored and can cause impediments, and that you can also see if you read about this or if you go out in an organization and study it for a while. People overlook the most strange things. This is, I'm trying to swap wheels on my car using a kind of strange tool here. And this is not that unusual for what people try to do in testing sometimes. The impact of an impediment is that everything goes slower. If we have optimal performance in the development process, we have the efficiency, which basically is the cost, and we have the effectiveness of the process, which is how we fulfill what we expect to do, the requirements on product. But when we get an impediment, we reduce the efficiency, everything gets more expensive, everything takes longer time, and we have to spend more money to get the same thing out of the company, basically. So that takes us to the research questions. The first one asks which, if any, types of impediments are encountered by software development organizations as a consequence of using software test execution automation. And the reason is that improvement and risk management is simplified by understanding the things that are going on in an organization. The second question, what causes the impediments when we use software test execution automation in a software development organization, provided that we actually found some. We found some, by the way. And the information about the underlying cause will simplify mitigation and prevention of the impediments, because if we don't know what's happening, if we don't have knowledge about that, how can we prevent it? And the third question is about priorities. Which are the most critical factors? What should we focus on first when we develop and implement automation? And knowing what's most important will help the project prioritize its actions. And I think that anyone that's worked in industry or is working in industry know that we tend to have a limited time to doing things. So we have to focus on what's most important first. This research has been performed as a combination of case studies and a systematic literature review. And the case studies were done to provide real data, both qualitative and quantitative, and we've done it through interviews, observations, and artifact review. And there are two purposes to the case studies, basically. One is to get more data, and one is to understand what's going on to be able to find where to focus. Then we performed a systematic literature review, and in short, what you do when you do one of those is that you very systematically search all relevant publications for information on the research questions. And then you perform a synthesis of what you have found. You collect the data and you try to interpret it as a collective, and then you make a statement about it. When we started the research, it started by business needs, essentially. Otherwise, I wouldn't do it as an industrial PhD student. I took my experience, and then we performed a very short preliminary literature survey. It was very ad hoc. It was basically Google Scholar, I would say. And this guided the objectives. And the objectives have been largely unchanged during the work. And one thing that we found, even by the brief literature survey, is that the research area is not widely explored academically on its own. There's a lot of evidence hidden within other research. It's hard to find. Lots of experience reports. And due to terminology, etc., if you search for test automation, it's quite interesting. You find a lot about testing airplane before they take off. So it's kind of hard to find things. But we concluded that there's short empirical evidence from industrial software test automation, and that was also one of the results from Rafi et al.'s SLR from 2012. They found a very small amount of papers also. If we look at some related work, there's a few ones that I would highlight. Most of it you can see in the systematic literature review, of course. Taipale, I'm a bit unsure about pronunciation here. Kasurinen and Karo, they did a large qualitative interview survey in Finland. They interviewed people from about 30 companies, and then they used grounded theory to form conclusions about that material. So there's 6 or 7 publications that are relevant. The difference from my work is that they looked at many companies. They did it on a high level. They talked to people, while when I've done my case studies, I've gone into the teams and I've been present where things are going on. This type of research was performed by Martin and Ruxby in 2 publications, actually. They've done what they call ethnographic studies of testing, participatory case studies, you could also call it, where they're trying to find out among other things, good reasons for bad software testing, what is happening and what is going on. Then there's a number of experience reports from, you could call agile context, and the reason I put agile context here is that most of it's published in the XP conference or in the agile conference. And it's the difference to research is that the experience reports are few people writing about, we did this project, this happened, and we think it's because of this, while in research you would set up a process, objectives, etc. beforehand and do the research. Experience reports, I think they are valuable. You have to read them carefully and see if they're well written, etc. But it's evidence also. You don't have the process, but it is at least equivalent to some person that you interview and have them tell you about their research, I think. Then one problem with experience report is that people seldom tell negative things, probably because their managers don't want them to do that. So there is a clear risk for positive bias in it. Then we have literature reviews. Rafi, Moses, Petersen et al. They did a literature review on benefits and limitations of automated software testing. Little fewer papers than we did, different research questions. They also did a practitioner survey in the same paper to evaluate the results from the SLR. Persson and Yilmaz-Turk did a literature survey that is part of their establishment of automated regression testing at ABB paper. They tried to identify pitfalls, they call it, for basically impediment classes for automated testing. Really, the only downside with that review is that they didn't perform it systematically, which I think is a pity because it's nice reading anyway. And then we have Mulder and White, who did a theoretical review of the impact of GUI-based test automation on test effectiveness. And it's similar to our review, but it's focusing on GUI testing and it's not systematic. After we've done the preliminary literature survey and we set up the research objectives, we started performing case studies. And case studies have been going on during the entire course of the research. So it's not blum, 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 something else. So it's been a part of the research all the time. And we did that at Ericsson, at different departments on different levels. We collected empirical data related to the objectives. How do people react? What are problems? How do people spend their time? And we got some various information about that, about what people thought could be the problem, what actually was the problem, etc. We mostly performed it using qualitative methods because, as Caroline Seaman says in her paper on qualitative methods in empirical studies of software engineering, human behavior is one of the few phenomena that's complex enough to require qualitative methods to study it. Basically, you can't set a number on people's behavior. Or you can, but it won't be a number. Then, iteratively, I would say the research questions formed. They were the same most of the time. There were some minor adjustments on it. And finally, we performed a systematic literature review to tie together the entire research. And from the literature review, we got an overview of the state of the art, what's published, what's not published. We were seeking for opportunities for generalization because our research was performed in our context. Are there similar phenomena in different contexts that we can compare to and maybe say that this could be something that's general for all types of software development? One finding here was actually that, as several other people have pointed out before, that people are not very good at describing context. So it's actually hard to say that we have this phenomena from this and this and this place, and now we have covered all these contexts. So it is, we got a development organization of this size, but they don't say exactly what it is, etc. Probably for confidentiality reasons. And we also wanted to set our research in relation to other research. As I said, how can we generalize our research or not? Okay, the results of the research. We do a number of contributions from the research. The first is a comprehensive list of impediments that we identify in the SLR. And this is a proposal for potential impediments. And we have classified them using thematic analysis. I got a better picture later. And classified them in a hierarchy, and we have put references on them to make it possible to look back and see where they occur. It's on page 153 in chapter 9 if you want to look at it in your book. The second contribution is a proposal for a qualitative model of interactions, a system between the main groups of impediments and how they, between the main group of phenomena and how they cooperate form impediments. And in a bit more readable size, it looks like this. I call this the spaghetti monster because that's what it looks like if you look at it in an unstructured way. But what you can do with this is that you can take a look at how the flow of events could happen. For example, if we start with business, which is the group up there, business aspects. Let's say that we don't allocate enough time and resources to do the development of the test system. Because the business implements how much we can spend on the test system. So we get some limitations in the test system. Then we have an impact from those limitations on the perceived value of the test automation. It was kind of hard to use this perhaps. And this will impact the behavior of people, maybe they have to do some process deviations as a consequence. And this in turn will impact the willingness to invest, because the test system didn't deliver, we had to do something to, as a workaround, we don't want to spend more money on it, and we get the spiral of debt for it, just as an example. And I think that there are many feedback loop of this type that you can identify in test automation that contribute to eventual failure of it. The third contribution, it's qualitative and quantitative data from case studies and the systematic literature review. And I have 3 examples here. One is from a case study we did on teams transforming to agile. What impediments and how much of it, how many impediments of each type are encountered. And we sorted this according to the rational unified process to make it possible to generalize it later. How many publications are available per year? And the third one is from another case study where we looked at what people actually are performing in different teams, what effort are they doing on different tasks. Then we have the answers of the research question. The first one, which if any types of impediments are encountered in an organization using software test execution automation? And the conclusion is that users of automations should expect to encounter a large number of impediments. And the top classes, this is a more readable version of the previous picture, are grouped into organizational impediments, behavior, business, communication, skills, and then they have technical impediments, test system, and system under test. IT environment, system under test, and finally the test system itself. The second research question, what causes impediments, is much harder to answer, I would say, because proving causality sort of is a hard thing. So we propose some ideas for this. And trivially, you could say that there's a lack of insights into the behavior of the project. And this, when I talk about why I do this research, people usually say, but why don't you just do it right? Because if everyone were doing it right, then we wouldn't have any problems. And we explored this through the synthesis in the systematic literature review in more detail. And we have proposed some reasons. For example, selecting the correct test system is very important. If the tool selection is done without concern for process, the system on test, the result may be that selected tools are unsuitable for the work. And it's really trivial, but people do this all the time. The third one is about how we should prioritize. Which are the most critical factors that cause impediments? And I think it's likely that no single impediment will make or break the automation effort, because one thing we can sort of handle one thing. But when we get the larger system automation, lots of people involved, we get this feedback and interaction. And that is why we have proposed this socio-technical system. I borrowed that term from Martin, I think, that we need to manage in a balanced way. So we have to make sure that these 5 main groups are managed together and we don't just focus on one thing, because then we will fail. We could, for example, make the perfect test automation system and do a lot of effort in the test system box, but then we'll probably starve something else, education, for example. We have identified a few candidates for future work that I think are worth mentioning. Pineiro et al., they did a really nice paper on testing the test environment. And they, by deploying testing of the test environment before they start to test, they saved orders of magnitude of time on work. And this is also one of the other trivial things, because if you use a software system, which test automation is, then you will test it beforehand, right? Apparently, testers don't test their test systems. I think this is a good opportunity for replication. Anyone working for a company doing test automation and don't test their test system before using it should start testing test system and write a paper about the benefits. Because here I think we are onto something. So please go ahead and do this research and publish it. Another consideration is centralization of tools and equipment cost effective? Because if you look at it from a purely business point of view, that was the upper box, it said business. Then you would think that, okay, let's take all the test tools we have, 4,000 of them or something, and we replace them with a single test tool, and we have someone developed for it, and the developers are happy, and we save a lot of money. doesn't really work that way. Typically, people will get annoyed and the feedback time will be too long to get things into the test system. But there is probably a trade-off somewhere, a cost-benefit analysis to be done. I think we need to look into this. What do we need to do to successfully centralize tools? Because there are issues connected to centralization. There are issues connected to using commercial tools, which is basically the ultimate centralization. Then finally, I propose that we use the system model and the 5 key areas to produce a self-assessment model, similar to psychometrics. We do it to find out, we do a form where you can fill out, you score it, and you find out what's the weaknesses and where should we improve. And this will help us to manage the testing much as we manage the test automation in the same way we manage a business, like a balanced scorecard, because that's very similar to what the system model promotes. We need to have balance between the areas to make sure that we don't starve them or get feedback that is bad for us in the system. To summarize, we have looked at software test execution automation, which is a part of software testing, which is a much bigger problem, but this is only test execution automation. Testing is very expensive, and by automating the execution part of it, we believe that we can save lots of money and lots of time and make software development much more efficient. In particular, in agile development, it's important to have good test execution automation because the processes are such with the developers depend on it. They depend on the rapid feedback to be able to work agile. Unfortunately, usually when people automate, they end up in a Peruvian road over a mountain with a lot of crashes and things like that, and tend to get quite disappointed. To understand why people end up in that situation, we did this research and we contribute a number of things. We contribute a list of potential impediments and where they are found in literature. We have classified it and proposed a hierarchy for it. We have proposed a system of interactions that cooperate, if you put it like that, to the failure, that contribute to the failure by forming feedback. And we have also contributed empirical data that's used by ourselves in the research, but also can be used by other people in future research on test execution automation. Thank you.